For this particular question, we are told that we have a large metal ball and a small sponge that are dropped from a tall building. They are released at the same time and the metal ball reaches the ground first. So this is very clearly an air resistance question. Okay, the metal ball reaches the ground first, so this is a air resistance question. Alright. Now, it's important to understand that air resistance is proportional, to the speed of the object, or more specifically the speed square of the object, and is also proportional to the surface area. Okay? Now, however, the effect of air resistance on the acceleration, is going to be dependent on the mass, right? Depends on the mass. So it's important to remember that heavy objects are less affected by air resistance, and as such, they accelerate more. And hence they reach a higher terminal velocity. Higher terminal velocity. Alright, so with this in mind, let's take a quick look. Now, the question then asks which statement explains why the metal ball reaches the ground first. Okay, so for option A, we have a gravitational field causes heavier objects to accelerate faster than lighter ones, and we know that this is incorrect because a gravitational field is going to be the same, the gravitational acceleration is the same on all objects no matter what. Near the surface of the earth, the gravitational acceleration is going to be 9.81 meters per second square, or in your secondary school syllabus, it's going to be 10 meters per second square. Okay, so for B, it suggests that the acceleration of free fall depends on the mass of the object, and it's mentioned because acceleration of free fall is always 10 meters per second square. Alright, this is also going to be untrue. Okay, so for part C, it says that the metal ball reaches a greater speed before the air resistance on it balances its weight, and this was essentially what I explained just now. The effect of air resistance on acceleration depends on its mass, and heavy objects are less affected by air resistance, hence they accelerate more, leading it to have a higher terminal velocity. So the air resistance balancing the weight, this is what happens when terminal velocity is reached. So as such, alright, C is going to be our answer. Now, let's take a look at D. D suggests that there is a smaller force of air resistance on lighter objects, and we know that this is not necessarily true. As mentioned, air resistance depends on the velocity, the velocity squared, as well as the surface area, and air resistance does not necessarily depend on the mass. Alright, so as such, our answer for this once again is C.